All right. Yeah, welcome everyone. It's the day after the big day. F# 8 was released, and of course, you know what we will talk about today. But before, let us do a small reminder why amplifying F# exists. So if you use F#, it's pretty much for sure that you use a ton of open source. And yes, there is Microsoft, but Microsoft doesn't take care of everything. So our idea was to encourage people and also companies to give back to the ecosystem they use. So if you are a decision maker, a manager in your company, please think about giving back to the ecosystem, sponsoring some maintainers, some open source contributors, or think about giving time for your own developers to contribute to the ecosystem, because that's the only way we can make this a sustainable situation. So if you are a developer, think about joining us in a session. If you have a GitHub issue, if you have a feature, raise an issue with us, get in contact with us. And yeah, we can talk about having a session of you. And you can do something nice like Paul last week. Wait a second. He had a session with the FSAC guys, with Jimmy and Chad, about a better error handling in the FSAC code base. And yeah, it was a really nice discussion. A lot of people enjoyed the session because we really talked shop. And yeah, the results got merged. So yeah, everyone can enjoy better error handling in FSAC today. All right. But of course, the big news and the big topic for us today is the release of F#, which happened a couple of days ago. Thomas did a really nice job of giving an overview in his blog post in the dev blogs on Microsoft.com. And we want to highlight some of the things that happened during the development. We want to highlight some of the contributors, and we want to highlight some of the things that happened in amplifying F# sessions. Give a little bit of a background story where we were involved, because it might be interesting for you to know. So, of course, if you want to get really into the details, read the blog post. But there was also a session Thomas did a couple of weeks ago, where he also kind of showed the most important stuff that's there. So you can watch the recording for a quick overview if you don't have the time to read the details. So we have like quality of life improvements in the features. We have now these very nice lambdas or a simpler piping operations mostly. Before you had to do a real explicit lambda. Now you have these shorthand lambdas. Tooling for this is on its way. It will come to an IDE near you shortly. A lot of people really like this. We have the nested record field and copy update. Also a great quality of life improvement. We have the while bang. A lot of people are really happy to have this. It will also make writing async code short and concise, as you can see here in the comparison. I think this was a community contribution, right, Edgar?
Yes, most of the language features, I think this version has been have been implemented by the community, especially Kerams, which, you know, it's a really prominent contributor of F sharp compiler. And yeah, so thank you, Kerams.
Definitely. All right. String interpolation, also a big quality of life improvement. Let's go on. Arithmetic operators and literals. I think also a thing of Karam's, if I'm not mistaken.
Yes.
Yeah. Shout out. Yeah. A lot of people were kind of surprised in the past that this wasn't working up till now. But yeah, now you are covered. Yeah, way nicer type constraints. Intersection syntax. Before you had to write an and do this kind of cast for the constraint types. And yeah, now you can do an ampersand and this hash kind of syntax, which you might know from dynamic types, flexible types, sorry. And yeah, extended fixed bindings, easy extension methods. I don't want to go into all the details here, of course, just a quick
I
overview.
will I will talk a little bit about the extensions one when it comes to showcase the contributions that we did in amplifying F sharp, because that was the extension one was a really great effort from Florian and myself. So yeah, I will show a demo, you know, why that is important. So I will expand a little bit more in detail on that one later.
All right. Yeah, the language was made a little bit more uniform. So before you had a little bit of constraints, which kind of types you could um, enhance with a static member, and now that's more uniformed and makes just more sense. Less surprises are always good in the language. What else? Let's go down. Yeah, twice and sequences now. And oh yeah, new diagnostics. The tail call attribute was yeah, the big story for me. I will go into the details a little bit later. And static classes, diagnostics. The warning about types being inferred to have type object, or values to be being inferred to have type object was kind of done in one of our sessions. We will also go into the details later on. That one was with Patrick. Yeah, the trim features were improved, and this is actually a real big one here. Parser recovery done by Eugene. We want to give a big shout out to Eugene because people might not realize how important this is, but it will have an effect, a great effect on all users, regardless of which IDE you are using. This parser recovery is yeah, a big improvement for all users. You will especially see large improvements if you have like large F-sharp files. You have some syntax error at the very beginning of it, and in the past, yeah, the rest, very often the rest of the file was pretty much unusable. And with the parser recovery work of Eugene, this situation has improved largely. He talked about the details in the session of amplifying F sharp. So check our recordings for the details. Really interesting and super important work by Eugene there.
Yeah, I think this is enabled by default in the F 8, I think. So if you are using, for example, Visual Studio, Ionide, I think in the it's also supporting Net 8 in a few in this really soon. and right that you will, and Visual Studio, you will see how the basically the code analysis or the error recovery, it's, it doesn't, as David said, doesn't break the rest of the file. It's like, you can keep getting your intelligence, you can keep getting, you can see that just because you are modifying the top of the file, the rest is going to be broken. So it's really great work by Eugene, and also from JetBrains. So thank you.
Yep. All right. Yeah, strict indentation rules. Also, there were some inconsistencies regarding the indentation rules. That was also work by Eugene. Autocomplete improvements. Struct unions can now have more than 49 cases. Yeah, we talked about this quite a lot. Compiler performance got improved. Yeah, I think if you check the recordings from our sessions, you will hear a lot of details about the graph type checking, graph-based checking, and yeah, good stuff and really important stuff. Okay, let's see what else. Enhancements to the F# standard library inlining, also important. Yeah, a lot of the collection functions got improved quite a lot by the F# team.
This I think the list contained was contributed by Jidrik. That was I saw an issue that where he showed the benchmarks how it was failing before, and then it was took over by the F# team. But yeah, it was really good to see.
Okay. Okay, let's scroll some more. Yeah, you can see the really great improvements here in the benchmark results. Some async improvements. And yeah, the F# team is really nice, giving shoutouts to the community, to all the contributors. Yeah, thanks for taking notice. And yeah, personally, I also want to say thanks for picking me as one of the 2 contributors being showcased here, besides the great Eugene. Great honor for me.
Well deserved. Well deserved.
Yeah, and also all the people being singled out here, and yeah, all the people raising issues, all the people contributing to the documentation. And yeah, it was a real nice team effort, community effort, which yeah, was finalized in a beautiful version 8 release a couple of days ago. So yeah, let's go into some of the details from our point of view. So one of the very first things I did when my job with G Research open source team started was to improve the situation regarding the fallback of XML of XML documentation. If you have a documentation in a signature, it was not always the case that this would be used if it wasn't also copied in the implementation file. So I worked on this as one of my first issues back in March. And it was from the get-go, really nice interaction with the team, with Tomasz and Petter. Thanks for the support to get me started there. And yeah, you can see some of the results here. For example, this was before you didn't really get the documentation in the tooltip here, but after the merge, you have here the fallback from the signature file, and yeah, that works now for disk unions, modules, for types, type fields, and yeah, it's a much more uniformed experience for developers.
Definitely, yeah.
Let's see a little bit what was needed for it. So there's a file called signature conformance, and in this file, all the checks are centralized to make sure that the signature is being obeyed by the implementation. And you can kind of set the fallback XML doc here in these files by using the document that is inside of the signature to the implementation part. So that wasn't so difficult. You just needed to understand where to do the stuff. And yeah, it was a good first step into the compiler code base. Not too difficult, not too easy, just the correct level for me back then. And yeah, pretty much one of the first real contributions from my side. So the next thing for me was tail recursion. That was a big one. So this was like in the discussion for many years, actually, back in 2016 von Avi, the first try to implement it in a PR was made. A lot of people were big fans of it initially, but well, for some reasons, it did not get finished and not accepted. And yeah, because there was interest inside of G Research to have this. They paid for the development time for it. So yeah, I gave it a second shot. Back in May, end of May, I started. I needed some different approaches. The first one was inside of post inference checks because that's where the type 3 is checked. And I thought that would be a good idea to have the check there, but of course it pretty quickly turned out we need to do it in another place. So my second idea was to wait a second. Was to do it in the part of the compiler where the IL is generated, because there you can really see if the tail call attribute is really emitted in the IL code or not. But for various reasons, this was also not the right place. So the final approach, the third approach was after the optimization took place, but still on in the type 3. And it took me some time, but in the end, with help of many other people, it got merged by Petter back then. And thanks a lot for all the support there. And now we can see it in action.
Before you continue, I have to say that seeing you go through the applying the fix for or try applying that tail call logic in different places, it was really a showcase of how you need to approach, fixing a complex problem, which is, try the different approaches, different attempts, and then until you got something working. So yeah, I remember seeing your PRs. I was like, yeah, the David is onto something, and then he will. I remember it was like when it was merged, I was like, yes, finally, it's there. It's a good job.
Yeah, that was a very special day for me. I have to admit, yeah.
Yeah, that seems very like it's like a lot of work and have to do it multiple times in different ways because it is a very complex problem. It's
Yeah.
amazing. Most people would burn out from that. That's just like amazing how much
Uh,
effort you put
I,
into it.
And
yeah.
seeing the response or the reactions from different communities, like the Okal community, the Okama community, where they kind of have, I guess, the same problem or the same things, and they basically recognize that you shouldn't be using attributes for everything, but in this specific case using this attribute would definitely help the compiler to tell, hey, yes, I want to rely on a take call recursion rather than let the compiler just put it recursive and then it will blow up at some point.
Yeah. To just briefly show an example, I'm taking this from Thomas F#8 repository. You can see here two recursive functions. One is not tail recursive because the real last operation is this multiply here. So it's not tail recursive, but we annotated it with tail call. So our intent was to be tail recursive. And the second one is making use of an accumulator. And as you can see, it is really tail recursive. The call to the recursive function is really the last thing in the definition. And yeah, we should see a warning for the factorial classic. And as you can see here, it works. If we would take away this multiplication in the last spot, the warning should disappear as it does here. That being said, there was a bug fix because I missed something, which didn't make the cut for version 8, but will be included for the next version.
Which is 8 point something. It's not going to be, you don't need to wait 1 year to get the
No,
fix.
no.
It's going to be in the next, I don't know, in the next minor version, I guess.
Yeah, yeah.
Cool.
Is there any guidance around writing those kind of so you like you get that warning and you go, okay, now what? What do I do? Like, is there any other docs around that kind of thing anywhere? You know,
There were a lot of articles about writing tail recursive algorithms. I think if you do a little bit of digging, you will find something. Yeah. So the the bug fix that didn't made the cut for version 8 was a construct like this. If you call list collect and give it a recursive function, this should also trigger the warning. It will be in the future release, in the next bug fix release, but currently, yeah, sorry, it kind of missed. All right. Next thing was also done or partly done in a session of amplifying F#. Patrick did the session. It was about giving a warning if a value is inferred to have type object, because that might be a surprise for the developer in certain situations. And that is now also handled with a warning. I have a small example here. So you see list A is annotated to be of int list, and list B is just without a type annotation. And if I compile this, you can see here the warning that B was inferred to have type of list object, which might be not what you want. If you do a explicit type annotation here, the warning will be silent.
I think this is this is the feature that is disabled, isn't it? You need to basically is it a opt-in feature or is it never by default?
3559 is, I think, the one. Yeah.
Yeah. Okay. So you need to explicitly mark that as a warn on, so you can get this warning.
Yeah.
Nice.
If you are interested in the details, it's pretty interesting actually, because you can see how the type inference works, at least part of it. So you can see here that this function choose type R, solution, and range. And at the end here, Patrick added the code that emits the warning if the type was not refined. So if it stayed with the top type, which is object. So yeah, it's interesting to see how the type inference tries to get away from object, but yeah, sometimes it can't. It has not enough information, or there were no constraints. So if you want to dive into that kind of code, this PR is actually a good start. And yeah, watch the session. Patrick did a really nice job finishing this up. Okay, this is pretty much all what I wanted to talk about. So I give it up to Edgar.
Thank you very much. Can you give me permission?
Yeah, it's 1 second. Okay.
Right. Let's see. No, still no. There must be in the security tab, there is an option that says allow participants to share or something.
Okay, no.
Yes, now I can. Okay. All right, so let me make sure I share the complete screen. So you should be able to see right there.
Yes.
Right, so my main focus for F# was to help the language to have less oddities and less, places where you're going to get runtime exceptions or some CLR exceptions where because of the error reporting was missing or because, there are some gaps in the errors analysis. So in the version 8, I focus on mainly three, and so I basically focus on 3 issues. The first one was a warning or an error, depending if you have enabled the warns as treat warning as errors. The first one was a way to basically said that if your union case doesn't hold any data, like in this case, A doesn't hold any data, B holds data, which is int and int and int, but you can see here that this is still, you can use a discard pattern here. If you remove this, it's going to work. So when I was learning the language, I was like, well, this is confusing. Why this is allowed? And if, for example, you do some refactoring and you forget to remove your data, let's say, for example, I have a string here, and yeah, this will compile. But if you remove, if you change the data you remove, it will still compile. So if I remove this, I would expect, that this will go away as well. So this was there. So I was confused, and I say, okay, let's see how we can do this. And I remember at that time I was still in my first months working as a F# developer, and I was learning the language. I was like, there must be something I can do about this. And I remember reaching out to Florian, and Florian really kindly take me through the compiler, how to work with the compiler, how to look at the compiler. So it was a really good mentor, and yeah. So I basically, most of these contributions here are based on the knowledge that Florian transpassed to me over the last 2 years. So yeah, I asked him, hey, I have this issue. there must be a way I can, I can fix this. And he was like, yeah, I mean, you could look at this place, And he gave me pointers. I'm going to show the implementation in a bit, but just to basically highlight that you don't need to know everything about the compiler. The compiler is just a huge code base where if you spend enough time looking at the source code and knowing exactly where the phases are, you will be able to understand it a bit. I mean, we all have working big code bases where, you don't, the first days working on your work code base, you don't know what to do, but with enough, familiarity with the code base, yeah, you can do it. So basically, in order to show the before and after, I'm going to change the version to version 8. And if everything goes okay, we should be able to see an error here saying pattern discard is not allowed for a union case that takes no data. And this is correct, because now this pattern case here is not representing nothing. So you can get away with you don't need this. So I remember applying this a couple of days ago on my code base, and I had because I use the Elmish model, I use MBU with Fabulous a lot, and I had a lot of these community unions where in the past I just modified the union case, the case, and then I did it and the compiler didn't tell me that this was no longer needed, but it was there anyway. So I had to remove, I don't know how many of them were, maybe 150 of them. I was like, oh, wow. So now, the code is more, I guess, not, it was, before it was still correct, but now it's at least more consistent. And, it's not, someone who is learning the language will expect this to not be there. So yeah, that was the good one. So in order to show the implementation was quite straightforward. So I started by looking at what Florian told me. It was like, hey, look at the check patterns, because that's a pattern. You're checking a pattern, and then look for the sympath.while, and then with some TDD, if you want to call it, basically, I was able to say, okay, so if we put this behind a LAM version preview, but basically, if you check for these conditions, and you will be able to raise your new warning. And what was not an error, a hard error, because there was previous code bases that will have this, and we don't want to break their code bases just by like that. So we added a warning with a new error number, so you can, in case you don't want to fix your code and you want to keep it as it is, you can just ignore the warning, and that will do it. So yeah, you can see another thing that was interesting to see is like when I did this change and I had all my tests passing locally, I realized, well, I have 100 something failing. So the compiler was the CI and the compiler was telling me that there are it's not compiling because there are 100 something places where the compiler was using this wildcard here. So I had to go all through the code base removing this, which it's a feature that benefited also the compiler itself. So yeah, it was kind of interesting when people were reviewing this PR. I think what was there? Peter said something like that. I was scared to review this due to the number of files, but then I realized that the analyzer that I did is going to help the compiler itself to clean it up. So that was a good one. Also, because this was one of my first contributions on the compiler itself, I created a blog explaining, a step-by-step how I did it. And this was part of the Advent calendar from last year, and where I basically explained you how you can add a warning, what was the analysis that I did, what tools did I use to investigate this, what was the abstract syntax tree, because at that moment I didn't know what was this. So that was something that for me was a jargon that I didn't understand. So, check out this devconflicts.com, and then you will see that all all of this here. I also did explain the implementation, and also that I also created I implemented this for Rider. So you can look at this on Rider. You can use this quick fix, and I also implemented this for Ionite. So it's and the F# team implemented this for Visual Studio. Yeah, so this will be available on all the IDs. Right. Next one. Okay, so let me come back to version 7 for now, because I want to explain something here. So the next one was the static classes error reporting. So static classes in F# is not a thing, because that basically is a feature by accident, I guess. And we know that that we have modules, and we have also static members on types, but the concept of static classes itself doesn't really is not in the language specs, and it's not something that has documentation or anything. It's something that basically, as I said, it was created by accident, I guess. But before, if you use in a type, if you use a CL attribute and a static class attributes, this qualifies this type to be a static class. So you can have, add your static members there, only static members, because nothing that is an instant is not going to be able to be instantiated, and it's not going to be able to call your static members through a static member. So I was like, I saw an issue that was, let's see if I can find it. There was an issue, maybe, yes. There was an issue that I found. Yeah, this issue that I found that says that no compiler error for instant members or static members produces invalid IL and produces runtime errors. So I was like, this shouldn't be the case. We can raise some warning on this to make sure that people don't have this code, and this code will compile, and it will actually produce invalid code. It will be a shame if we don't fix this. So what I did, I went through I basically read all about static classes, and I realized that, we can do better than this. So I went there and changed these implemented some error reporting on version 8, and now what was compiling before is no longer compiling. So you cannot have so you have now, if a type uses both sealed and a static class attribute, it means it's a static constructor with arguments is not allowed. The same for default, the same for abstract members, the same for the same for values and all of that. So I guess I could do better by making sure that I'm using the more accurate ranges, and I might do that as a follow-up PR in the future, where I only highlight maybe the specific case rather than in the whole line. I didn't know better at that time, so that's why I'm using the whole range. But what I know now, I think this is not good enough for me. So I will definitely improve this to be more accurate ranges. But yeah, we now have a proper error reporting for static classes, which in theory they don't exist in F# as a language construct documented or in the spec, but it is there nevertheless. Right, so let's put back. And the PRs, it was a number of different PRs, basically. I started with the no constructor arguments allowed for static classes, and with what I learned from the previous contributions, and by looking at the the existing code that was managed, I was able to get a function here that will check for the members and then check if it's an implicit constructor, and then, you know, it has patterns when it's not empty, and basically add a check for that. Yep, and adjust the code a little bit, added a feature, because we didn't want to, this needs to be protected through a language feature. And yeah, the normal stuff that I talk in my blog about how can you add new error messages into the compiler, a lot of testing, and happy days. All right. Yeah, this was for the constructor itself. You can see that I did the same for the interfaces, let bindings, interfaces on static classes, and this was a little bit tricky because I didn't know at that time that there was going to be there was something with the static members on the static on interfaces, static member interfaces, which was then introduced with the how's that called? iWasm or something like that. The generic math basically in F#. So I had to change that in a follow-up PR, so that's not affected. And yeah, by adding more and more stuff there. Right, so next one is, did I change that to 7? Yes. Why is not? I guess I need to, let me unload this, reload this, so to help writer. Okay, but nevertheless, something is going wrong there. But as I showcase, it shouldn't be happening. Right. So another thing I did with the help and collaboration of Florian, it was an effort of allowing existing extension methods without type attributes. So this is the C# style extension methods that you can use in F#, but for that you need to add 2 attributes always. One on the type definition and one of the member definition. So if you do, if we're in version 7 and you do that, if I do this won't be found. It says, hey, no, you cannot find this. So you are forced to use both. But if I move this to, let me remove this because or comment this and this because it's really triggering me. And if I change this to 8, and now remove the attributes, it is now being found. So you no longer need to annotate both the type and the member with extension attributes, which removes a lot of typing when you, for example, in a library like Fabulous Maui controls or Fabulous Avalonia, that you have to define, you will rely a lot on extension methods. So that will free us a lot. We will be able to delete a lot of the code, and this is a warning that is from ReSharp itself, so it's not from the compiler. And this has been fixed by the JetBrains team, and it will be available, I think, maybe in the next early preview version of Rider. But yeah, these now because now they will support a .NET 8, so this will no longer be shown there. But yeah. So yeah, I think that was the 3, highlights that I want to said about the what I did with regarding F#8. A lot of things has been done with now with the once we got together with Florian, with David, with Jimmy, and myself. We started to, have sessions on amplifying F# about stuff in the compiler. So this session is not only about what we did or what will happen in F#8, but also what we are doing also for F#9. There's a lot of compiler fixes that we have done we have done in the current in the main of the F# compiler that will be there. I am talking about this index is not allowed to have mismatched values. That's not part of F#, but will be in the future. A lot of good stuff is happening as well. So yeah, that's it for me. Any remarks or anything you want to share?
No. Yeah, I think F# is out there. Enjoy, install the new SDK, give the features a try, enjoy the new warnings, improve your code, raise issues if you find a gap, a bug, of course, so we can improve what's out there. And yeah, I'm pretty sure we will do something like this for version 9 in a year or a couple of months.
Oh yeah, while y'all are chatting, I just released FS autocomplete and INI, so that should have a F#8 support now.
Work.
Great, man. Thanks.
That sounds amazing. But yeah, my whole experience contributing to F# compiler has been really, I wouldn't a smooth, let's say, experience in regards of people, being welcoming and being helpful and helping you on the issues and all of that. And I really want to highlight that is, it's not rocket science. You can, if I did it, everyone can do it. Everyone that has, the need, has the time, has the passion to do this, it can do it. And we are here to help you there if you really want to make a difference and you really want to get your hands dirty on helping F# to get better, because there are a lot of improvement, not only features that you can do, that we can do together. So that's my message.
All right, I have nothing to add to this. Okay, so see you next week. Have a good one. Bye.